Have you ever wondered how scientists figure out the mass of a whole planet? Today I'll show you how to calculate the mass of Mars, just using a little physics. Now, we can't just put Mars on a giant scale. Instead, we use a formula. This is the formula for gravity between two objects. This formula is a really important and standard one in physics. We have the force, we have G, which is the gravitational universal constant, two masses, and R is the distance between them. So, to calculate this mass, we need a whole bunch of inputs, variables. You might see the question written on the test this way. The Mars rover Opportunity has a mass of 185 kilograms. This is a real machine, the Opportunity, that was on Mars. Maybe it's still on Mars. On Mars, it weighs 684 newtons. What is the mass of the planet Mars? So we begin by writing our formula. F equals G m little m over R squared. Okay, so little m is 185 kilograms. That's the mass of the rover. The force is the 684 newtons. In physics, the weight is a force. So something in newtons is what it weighs. So that's the force of gravity. Really, it's the attraction force between that rover and the whole planet. What about big G and R? So big G comes from your formula sheet. You should have on a test a sheet, and it will say something like 6.67 times 10 to the negative 11 with some kind of crazy units. And R, if you look on my formula sheet, it says 3,390 kilometers. That's the radius of the planet Mars. So if you think about the planet and the rover on the top of the planet, the radius is the distance between the center of mass and where the rover is. So with this radius, there's a little problem, which is it's in kilometers. So we want to put it back into meters. That's going to be 3,390,000 meters, like that. So for this equation, I think it's easiest if we begin by arranging everything first. So what are we looking for? We're looking for this m here, the big M. So I'm going to begin by going F times R squared, G m m, and then divide big M equals big F R squared over G times M. Now we're in a place to plug in all those variables. So M equals, what are my variables? 684 newtons times this big number 3,390,000 squared divided by 6.67 times 10 to the negative 11 times the mass. That was 185 kilograms. Okay, so just a little tip here. If you're using a scientific calculator, which you may be doing on a test, this might be a little annoying to plug everything in. So you might want to begin by doing this one squared, and then timesing by that one, and then divide by that one, and then divide by that one. I'm going to do that so you can see what it is step by step with a calculator. 6, let's go back to black. 684 times 6.37 times 10 to 3 kilograms. Okay, That's really heavy. So 6.37 times 10 to the 23 kilograms. How big is that number? Well, to think about that number, I was thinking of a battleship. So some battleships could be as large as 72,000 tons, which is this many kilograms. What's that, a lot? 72,000 or 72 million kilograms. So if we plug that and divide it, Mars is 8.8 times 10 to the 15 times more heavy than a largest kind of battle carrier. If it was to the 14, it would be 800 trillion times. But to the 15, it's one bigger than a trillion. It's quadrillion, I think. So it's 8.8 quadrillion times larger, more heavy than a battleship. That's really, really heavy. Or you're right, 6 with 23 zeros behind it, which is a lot of zeros. Kilograms. So Mars is really, really heavy. I hope you enjoyed the video. If you liked it, please hit the like button.